Welcome everyone. Today we are going to apply seismic load to our building. So first we will open ETAP software and our building project we have saved before. Now we will apply the seismic load. To apply the seismic load, we will go to define menu, then load patterns. In load patterns we will enter seismic, then load type, we will select seismic, and in auto lateral load we will select IS 1893-2002. Now add new load. After adding new load, we will go to modify lateral loads. We can apply seismic load in the following direction, but for this building we will only apply for X direction and Y direction. So we don't need to change this. So this is seismic coefficient. For seismic coefficient we will have to refer the IS code. Then there is site type. Again we will refer IS code. Importance factor. Again we will need to refer the IS code. Then time period, it is automatically calculated, and the response reduction factor, we can find this in the IS code. This is IS 1893-2002. This is Bangalore. The city of Bangalore lies in zone 2. You can also see so you can also see the table 2 zone factor. The city of Bangalore lies in seismic zone 2 and the value of Z is 0.1. Now we will see the value of the importance factor I. So this is the importance factor, table number 6, importance factors. So for all other buildings the value of is 1. Our building comes under this category. We will take the value of importance factor as 1. Now we will go to the response reduction factor, table number 7. So this is table number 7. Value for ordinary RC moment resisting frame is 3. So our building has response reduction factor as 3. For special RC moment resisting frame, the value is 5. Now for soil category, we will go up. The soil category for Bangalore city is type 2, medium soil. You can see this here. Now we'll go back to the software. So as per the code, we will enter the value 0.1 seismic zone factor. The site type is set to 2 and importance factor will remain 1. The response reduction factor, as you have seen in the code, the value will be 3 for Bangalore. Now click on OK. So we have defined the load pattern seismic. Now again click on OK. Now after defining the load pattern, again we will go to the define menu. Go to load combination. In load combination, we will go to add default design combos. Select concrete frame design. Click on OK. So we have the default load combination. Now again we will click on OK. Now we'll go to analyze. Set load cases to run. Thus we have dead, live, and seismic. Click on run now. So now we can see the analysis result in the 3D tab. We can see the displacement of any point as stored in the previous video. Now we'll go to the design tab, concrete frame design, view revised preferences. You can see that we have selected the IS 456-2000. Click on OK. Now again we'll go to design tab, concrete frame design, start design check. The software is asking us to reiterate analysis and design. We will say yes. Once again we will reiterate the process. Yes. You can see that the design is complete. So we can go to design option, concrete frame design, verify all members passed. Now it is showing all concrete frame passed the design check on OK. So we have completed the analysis of our building with seismic load. Thank you. Now we will design our building according to the response spectrum method. First we have to unlock the model locked previously. After unlocking the model, we will go to the define menu, load patterns. Now you can see that if you have not defined the seismic load, you need to define the seismic load. And after selecting the seismic load, go to modify lateral loads. We have already defined these values, and we will keep the direction value as x direction and y direction both. We have already discussed about this. Again, we will go to the define functions and response spectrum. Now we will choose our function type IS 1893-2000 to add new function. We will change the name to response spectrum. Now after defining response spectrum, we will change the seismic zone factor to 0.1, soil type as 2, and then click on OK. You can see that we have defined the response spectrum function. Now click on OK. Now again we will go to the define function, load cases. Now here we need to add a new case for response spectrum. We will write the load case name as response spectrum. Now we'll select the load case type as response spectrum. After that we'll change the default function value as response spectrum. And for scale factor, we need to know the value of scale factor. So the scale factor is given by where I is importance factor, G is acceleration due to gravity, R is response reduction factor. So the scale factor is given by the following value. Now we will add another load for y direction and change its value to u2. This value to 1633.5. Now we do not need to change any of these values and click OK. So we have the response spectrum load case. Now we'll go to the analyze and set load cases to run option. Now since we have to do the response spectrum method, we do not need to run the dead and live load case. So we'll change this value to do not run. Now click on run now. So now the analysis is done. You can see the displacement values. You can click on any point and see the displacement value. Now we'll run the design. You can see the IS456 2000. Click on OK. Now click on design again. Complete frame design. Start design check. So as the software has designed our building model, we need to verify all members pass the design check. Design, concrete frame design, verify all members passed. All concrete frames pass the design check. Click on OK. Now the response spectrum method is complete. So now we have designed our building as per the response spectrum methods. Thank you. Okay, so now we are going to analyze our building according to the time history analysis. So first we'll go to the define menu. In define menu we'll see the load pattern. In load pattern we have seismic. We'll select the seismic. We'll go to the modify lateral loads and check only x direction. So we'll perform our seismic loading for x direction only. These are the values we have already explained in the previous part. Click on OK. Now we'll go to the define menu again. Go to functions, time history. In time history we'll choose from file and add new function. Write the function name as time history. We'll browse the file, time history data. Now we need to specify, first we'll change this value to fixed. To enter the value of header lines to skip, we need to see the file. We'll click on view file. So the number of header lines to skip is 9. We will go back to the software and we will enter 9. Number of points per line, we will enter the value 1. Now we will click on OK. Now you can see time history data function has been defined. Now click on OK. Now again we will go to define load cases. We do not need the response spectrum, so we will delete response spectrum. Now we will add new case for time history. Load case name. Load case type. Time history. We'll change this load pattern to acceleration. Load name as u1. We'll change the function value time history. The scale factor already calculated, you can see in the previous part, and click on OK. So now we have time history load case. Now we will click on OK. Now we will go to analyze, set load cases to run. As you can already see, the dead and live load case has been set to do not run, so we do not need to change anything here. And we will run now. We will run the analysis now. So now as the analysis is complete, we will design our building. Now we'll again go to design, concrete frame design, start design check. So the software has done the designing of our building. Thus we have completed the method of time history analysis for our building design. Thank you.